learn how to graph linear inequalities in two variables. And so this is not a real difficult topic, and we're going to go right to an example here. Let's say that you are asked to graph a linear inequality that looks like this. 3x minus y is less than 2. Now, the first thing I want you to notice is that it's not in slope-intercept form. All right, slope-intercept form is y equals mx plus b. So if I'm going to graph a linear, I need it to be in this form. Okay, the y equals mx plus b form. All right, and I'm going to make this a little bit bigger for you. There we go. So let's do some algebra here to get this in slope-intercept form. I would subtract 3x from both sides first. Subtract 3x from both sides. And because we're trying to get this into mx plus b form, I would write it this way. Negative y is less than negative 3x plus 2. I would not write it as 2 minus 3x. Only one more step here, and that's to divide everything by a negative 1. And we learned the last time that if I divide by a negative when I'm solving an inequality, that I have to flip this inequality sign. So now I have y is greater than 3x minus 2. So now we need to graph this thing. So if I graph this, I just simply graph the linear like we always do. This is my y-intercept, and this is my slope. So my y-intercept is negative 2. Come down to negative 2, put a dot. My slope is 3, which is actually 3 over 1. So I'm going to go up 1, 2, 3, up 1, 2, 3 over 1 to get my next point. Now I could do that again, of course, 1, 2, 3 over 1, and I'm up here someplace. Now don't draw the line yet, all right? Because it's an inequality, I've got a couple things I have to look at. If it is greater than or equal to, or less than or equal to, I use a solid line. But if it's only greater than or less than, I use a dashed line. All right, so you need to know that going in. This problem that we did is only greater than, so I'm going to use a dashed line. To draw my line. And because this inequality is saying, show me all of the y's that are greater than 3x minus 2. What we're going to do is we're going to color this entire area over here. And I don't have a crayon or marker or something to do all of this, but I'm going to color the entire area up above that line when it says greater than. If it would have said less than, then I would color below the line. All right, let's do another one. Let's say that we had x plus 5y is less than or equal to 10. Once again, we are not in slope-intercept form. Let's get it in slope-intercept form. So I would subtract x from both sides. Now I have 5y is less than or equal to negative x plus 10. And I would divide both sides by 5. Divide that side by 5, and everything over here by 5. So these 5's cancel. I did not divide by a negative, so it stays as less than or equal to. Now this negative x over 5 sometimes confuses people. That slope, it's negative 1/5 x. That's how you write that. Plus 10 divided by 5 is 2. All right, so now we have it in slope-intercept form. Now we can graph it. We will once again start at the y-intercept, which in this case is positive 2. Positive 1, positive 2. And the slope is negative 1/5. So from this point, I'm going to go down 1 over 1, 2, 3, 4, 5. And because it is less than or equal to, I can make a solid line this time. And because it is less than, I'm going to shade below the line. All of this area down here. That is representing all the solutions to the inequality. Now, the only other thing we need to talk about is vertical and horizontal. Because we're talking about linear inequalities in two variables, we have to talk about vertical lines. Okay, remember, you can have a vertical line if the equation does not have a y in it. Like, I'll call this example 3. This is really short. 3x plus 5 is less than 14. If they give you that and say graph it, well, you've got to notice there's no y in it. There's no y. So solve it for x. Subtract 5. 3x is less than 9. Divide both sides by 3. X is less than 3. This is a vertical line. Where do you put the vertical line through? Through 3. So you just put a vertical line through 3. Now this one is less than, so we would do a dashed line. And because it's less than 3, you would shade to the left. All right? And for a horizontal line, horizontal, I'm not going to do another example, but a horizontal line, that happens when there's only a y and there's no x. Like if I would have had 3y plus 5 is less than 14. If that would have been the equation, then when I solve it, I get that y is less than 3, and you would have a horizontal line through 3, and you would shade below. All right, so that is what happens if there's only a y. It turns out to be a horizontal line. So that is a good introduction to graphing linear inequalities in two variables. And hopefully that helps you today, and you have a good rest of your day.